Hey everyone, welcome to 5.2 Natural Log Functions and Integration. If you remember from last video and last section, the derivative of the natural log of the absolute value of x equals 1 over x, and the derivative of x, the natural log of the absolute value of u, is u prime over u. Now you might say, I don't remember seeing this absolute value here before. Why do we have the absolute value? Well, that way I don't have to say x is greater than 0, because the natural log function is only defined for x greater than 0. So that's how they kind of get around saying this is for x is greater than 0, they just say absolute value of x, and then we're all done. Okay, so here are some log rules for integration. The integral of 1 over x dx is the same as a natural log of the absolute value of x plus c. The integral of 1 over u du equals the natural log of the absolute value of u plus c, or we could say u prime over u dx equals the natural log of u plus c. Great, so those are the rules. I'm sure that you probably kind of know them already, but officially now you have them. So as you're going through some of these problems, you're going to say, I don't know how to do this. I've never seen this before. What do I do? I don't know what to do. Ah! That's fine. Here are some ideas for you. Number 1, you have 12 formulas for integration. Power rule, log rule, and 10 trig rules. Know them, memorize them. Know them like the back of your hand, or like your passcode for your phone, or something like that. Know them really well. Number 2, find the formula that represents the integrand, which is the stuff that comes after the integral, and then look for a u. That way you can maybe use some u substitution. Do something like that. Number 3, try altering the integrand. Try like a trig identity, or multiplying and or dividing by some quantity. That way it kind of changes it up. Maybe that'll help out. Or number 4, use your calculator. Okay, so these are all the things we're going to do. This is really the only new thing that we have, and now all we're going to do is just give you a whole bunch of examples for how to work on this. Let's just do an example here to make it a little bit shorter. But before I do, I'm just going to remind you of all of your integrals for the 6 basic trig functions. Okay. Integral of sine u du equals negative cosine u. Integral of cosine u is sine u. And of course all these are plus c. Integral of tangent u is negative natural log of the absolute value of cosine u. Integral of cotangent natural log of absolute value of sine u. Secant u is the natural log of secant u plus tangent u, absolute value. And cosecant u is the negative natural log of cosecant u plus cotangent u, all again plus c. Alright, so these are your 6 basic trig functions. We have 1, 2, 3, 4, 5, and 6 of them. 6 basic trig functions. Okay, let's just go through and do one of these. We'll make this a pretty good sized video just for the sense of getting a couple of these done. So we can say this is going to be the same as the integral of 2 over x dx. Well, let's just write that as 2 integral of 1 over x dx. Right? There we go. Okay. Then you go back and say, well, Mr. Marvin, I don't know what to do. Actually, you sound more like this. Mr. Marvin, I don't know what to do. That's what you sound like. So let me help you out. Integral 1 over x dx equals the natural log of the absolute value of x plus c. So really, this is what we're using right here. Right? Isn't that the exact same thing as what we're doing right here? I mean, let's see if we can look at this. There it is. There it is. Okay, so this is going to be the same as 2 natural log absolute value of x plus c. And here's a quick thing. When you have 2 in front, if you know your log rules, we can say this is the natural log of the absolute value of x squared plus c. But if you take the absolute value and square something, it kind of does the same thing. It makes it positive. So we can really just say this is the same as the natural log of x squared plus c. Alright, makes it a little bit cleaner, a little bit nicer. Kind of like me. There you go. How hard is this going to be? Not too bad. Okay, so now we have the next one. Uh-oh, we've got a 4x minus 1. So can we do something with the u? Sure. Say u equals 4x minus 1. Say du is going to equal 4 dx. Right? So then we can use our u substitution. Divide by 4, divide by 4. And I can say this is going to be the same as 1/4 the integral of 1 over u du. Okay, so that means it's going to be 1/4 natural log absolute value of u plus c, and then we can say that's the same as 1/4 natural log absolute value of 4x minus 1 plus c. Okay? There we go. So we can use u. And now we have the last one here, number 3. Find the area of the region bounded by y equals x over x squared plus 1, the x-axis, and x equals 3. And you say, I don't know how to do that. I don't know what that looks like. Well, here it is. There is exactly what this looks like. So we have our function right here. It's right underneath me. Watch. See? It's up here. And then x equals 0 is this blue line, and x equals 3 is this green line. So we want to find the area that's in this region right in here. Okay? So basically, I want to find the integral, right? We're going to find the integral. That goes from 0 to 3 of x over x squared plus 1 dx. Right? Yes. Okay. So now what I'm going to say is let's set u equal to x squared plus 1. Let's set du equal to 2x dx. And I've got this x in the numerator. I don't have a 2, so I'm just going to divide this by 2, divide this by 2. And I'm going to put that 1/2 out in front. So I can say this is going to be 1/2 integral goes from 0 to 3 of 1 over u du. Okay. Now I can say this is going to be the same as 1/2 the natural log of the absolute value of u plus c. So I can say this is 1/2 natural log u is x squared plus 1 plus c. Right? Yes. Yes, it is. Okay. Good. Now, what we're going to do is we're going to take this and we're going to evaluate it to say this is the same as 1/2 natural log absolute value of x squared plus 1 from 0 to 3. Now here's something to think about. If I take x squared plus 1, isn't that going to be a positive no matter what? Do I really need this absolute value to say take a number, square it, add 1, then make it positive? That seems kind of ridiculous. I don't have to do that. So now what I'm going to do is I'm just going to say this is the same as 1/2 natural log of x squared plus 1, and then evaluate it from 0 to 3. Okay, so we're going to do that, and in just a second I'll show you what it looks like on the calculator. Okay, so now I'm over here, and what we're going to do is go to math. Let's go down to number 9, and let's just plug this in. Maybe we can just do it this way. Go from 0 to 3 of x divided by, and it's x squared plus 1. Close that parentheses, and it's dx. And if I go through and I get this answer, it's going to be 1.1. So if I actually go through this, I can say that's going to be the same as 1.151. Okay. Now if I didn't want to do that, I can also take the natural log of 3 squared, which is 9 plus 1 is 10. Enter. And then divide by 2. And I'm going to write that as 1.51. Look at that. And I'm guessing that the natural log of 0 plus 1, let's just take a look. Natural log of 0 squared plus 1 is going to equal that. Equals 0. So look at there. There's my answer. I got the same thing either way. Okay? Let's see if I can keep on moving over here. Yay, there I am. Okay, so there we go. There is your answer. There is your solution. About 1.51 square units, whatever our units happen to be. Alright, so I'm going to have you stay tuned for a few more example problems on how to use integrals and some of these transcendental functions.